Today I want to talk about animations in SwiftUI. And there's many things to say about animations. We can talk about the theory, about curves and all of that, and continuity. We could talk about the design of animations, but we're only going to focus on how to do this in SwiftUI, the SwiftUI part. And there are many ways, and we'll only cover 4 ways of doing animations. The first thing we'll look at is a regular animation, which will let us allows us to animate a stroke or all kinds of other stuff. The second way we'll look at is phase animations, which allow you to do more animations in phases. Then we'll have a look at keyframe animations, for example, one like this. And then finally, we'll look at particle animations. The basic animations in SwiftUI will get you very far and will take care of most of your animations for you. In this case, we want to animate the stroke of this heart. The first thing we'll do is wrap this heart in a Z stack and add another copy of it with a red stroke, which overlaps the previous stroke. And then to animate this, we need to somehow make that stroke shorter, and we can do this using the trim modifier. So we can trim, for example, to 0.5, and then we'll only see half of the heart, or to 0.75, and we'll see 75% of the heart. Now, the thing we want is to animate that value, right? And so we'll add a tap gesture and we'll add a state property. And the line where it says 0.75 is the thing that we want to animate. This should be either 0 or 1, depending on the current state. And so now if we change that to a ternary, we actually have 2 different states. But nothing is animating, and we want that line to animate for us. And so this is a moment to think about what does it mean to animate. And in terms of a computer screen, we're drawing frames at 60 times per second, or maybe more often. And to animate something is over a certain period of time to draw different frames, to draw intermediate values. And so in our case, let's say if the animation would take 1 second, we want to show it with a stroke trimmed to 0 at the beginning, at 1 towards the end, and all the intermediate values in between for every frame of the animation. These values in between are computed using something called interpolation, and if we interpolate over time and have different values there, then we have an animation. Luckily, this is very easy to do in SwiftUI. So we can just say, well, first make it add a heart content shape so that the entire heart is tappable, and then finally add our animation and say we want to animate whenever the isOn value changes. And now if we tap it, we can see it animating. And again, many of your SwiftUI animations are as simple as this. Now what's going on here? It helps to look at the render tree. So here we have our instrument to look at animations, and we can have a look at the render tree here for us and go back to the start of the previous animation where we were true. The isOn was true. This render tree on the right here is kind of like the attribute graph. It's a tree that persists over time and is always there. Or you can almost think of this as a UI view tree if you're coming from UIKit. And it's created by executing our view tree, the code that we wrote. And we can see now if we change this value to false, how it's going to start updating. So first it'll start updating the stroke animation. It then goes and updates the subtree of that, so the frame animation, and the frame updates the tap gesture. And you can see in between this frame and the tap gesture that there's some kind of symbol. That symbol represents the current transaction. Every state change has an associated transaction, which is passed through the view tree as we update for that state change. The transaction contains things like the current animation. And we now hit our tap gesture, the transaction is still empty, and we hit our animation, the value changed, and now we can see that the transaction is changing as well. And that's what the dot animation does for us. It will add the current ease in out animation to the transaction. And so this transaction can change locally as we go through the view tree and update the children. The content shape has nothing to animate, passes on the transaction, the v stack the same way, the tuple view. the first heart doesn't change, but the second one, and we have the trim value that changes. And so if we look at this and tap on this, we can see it going from 1 to 0. And this is where we add the animations. And so the animations are added to the render tree for every animatable property if there's something that changes. And we can actually look at the timeline as well. So over here we have our timeline for the last two animations, and we can see that as we go through time that the to property changes, so the timing curve increases and the corresponding value also changes. And so we were in this case animating from 0 to 1, and so as we go through the entire animation the value eventually will be 0. Now this is roughly how that works. Of course, in reality, it's a little bit more subtle, but this is a really good mental model to think about these animations. One other quick debugging technique, if you're dealing with animations, if you want to actually see what's happening, is to just make your animation slower using the speed modifier. Don't forget to take that out again, because it changes the type of your animation and also the way additive animations can merge. Okay, we saw how to animate from A to B. So the SwiftUI system takes a snapshot of the view before, a snapshot of the view after, and it animates any changes. But what if we want to animate from A to B via C, or from A to A via B? For example, if we want that heart to jump out and rotate and go back to the center, to its original position, how would we do that? This is where phase animations come in really handy. They basically allow you to describe a set of phases that the animation needs to go through, and it'll animate through each of the phases using a completion handler to animate to the next phase. So we want our heart to change and fill with either red or gray, and then animate that change, and now it animates, and also scale up and back down. And to do that, we'll use a phase animator. So we'll wrap our entire heart in a phase animator, and we can see here that there's two phases. You can use any equatable value you want. In our case, I chose bool because we only have the two phases, false and true. And so false represents the view at rest, and true represents the view in its active state. Then we have a trigger value, which is when the animation should start. So anytime the is-on changes, we want to animate through those phases. And SwiftUI is going to render a view at rest using the initial phase, false. Then anytime is-on changes, it's going to animate to the second phase, true. If there were more phases, it would animate through all of these phases until it hits the last phase, at which point it animates back to the initial phase. So in this case, it'll animate from false to true, and then back from true to false. If we would use this Boolean, we can do something with it. So we will make our hearts slightly smaller, so we have some room to play around with, and then we'll use a scale effect, depending on the active Boolean. And so now if we tap it, we can see it fading, the color, and at the same time scaling up, and then after the scaling up is complete, it scales back down. And so that's what the phase animator does. We can make that scale a little smaller. That's better. We can add a rotation effect and start with 45 degrees, maybe, well, 22 might be better. Still a bit much. 13 sounds or looks okay. Then we'll add an offset, and then we have our phase animation complete. And phase animations are really great if you have discrete phases that you want to animate through. Sometimes, however, you want to animate multiple things at the same time, but maybe not at the same start time, or maybe also through different phases, but you want to have different phases per property. And that's where keyframe animations come in really handy. Here we have a heart that's filled with 10% opacity, and it has a stroke. And we want to animate both of these properties depending on the off or the on state. So we can do that with a trim modifier and a ternary, and opacity with a ternary. And then now if we tap it, we have the two phases. We can animate the change, but this doesn't look right. we are filling and fading in, or filling the stroke and fading in at the same time, and that just doesn't feel right. It would be much nicer if we could first stroke the heart and then towards the end start fading it in. So let's do that, and we can do this using a keyframe animation. With a keyframe animation, we are moving to a whole different realm of animations. We're not just animating the view tree anymore, but the keyframe animation will allow us to animate a value. So the animations are really sort of inside the keyframe animator and not so much inside the view tree. The keyframe animator takes an initial value, it takes a trigger just like before, and it has a closure for where we can describe the keyframes that we want. The initial value of 0 is just a placeholder, and I found what works really well for me is to have a struct for my keyframe animator and have one property in that struct per thing that I want to animate. In our case, we want to animate the opacity and the trim progress. So we'll create a struct with two properties for that, and then we can create two initial values for the off state and ones for the on state. And we can use those in our keyframe animator, and also in the closure we get the current value in. And so now we can see, we can tap, and it has a different initial phase or initial value. But we of course want to describe how that value changes over time. One thing to remember with keyframe animation is that this closure will get called for every frame of your animation, so 60 times per second, 120 times per second, depending on the refresh rate of your display. We can use the values now inside the body, and still nothing much is happening because we're not describing yet how that value should change over time. And that's what we can do inside our keyframes closure. So we can have the opacity and have the trim there, and then what we're currently doing is saying the opacity should always be 0.1 and the trim should move to 1 second to 1 over the duration of 2 seconds. This means that the opacity will always be the same value and the trim value moves. And so now if I tap it, the trim jumps to 1, and if I tap it again, it animates to 1, and I'm not exactly sure, to be honest, what's going on there and how to exactly use this, but I can make the keyframe animations work for this example. What we can do is, in the trim keyframe, say, well, we want to start at 0 and then move to 1 over 2 seconds. And so now it always moves from 0 to 1. Then we can, of course, have a different animation for the different states. So we can wrap that inside an if-else and say, okay, for the else case, we want to move from 1 back to 0 over 2 seconds. And so now we can animate in between those two states. For the opacity, we want to do something similar. So currently, we're always setting the opacity just to 0.1. And what we can do is actually set it to 0.1 and then animate to 0.1. So this is supposed to sort of stay at 0.1 for 1.5 seconds. That's what I'm trying to achieve there. There's currently no delay keyframe or sleep keyframe or something like that. So my goal here is to just say, okay, we start at 0.1 and then we will stay at 0.1 for 1.5 seconds, and only then we will start moving to 1. And so for the first 2 seconds of the animation, our stroke is increasing, and then towards the end of that, at 75%, after 1.5 seconds, we will fade in the opacity, which will also take longer than until after the trim is finished. This doesn't compile yet. We also need an else case. So in the else case, we'll just move back to 0.1. So now if we tap it, we can see it stroke. Let's try it again. We can tap it, and now we can see the stroke fade in and then the opacity. And so that's exactly what we want. Nice. So that's what keyframe animations can give you, and it's a lot of typing, but the big thing to realize there is that you're animating the values and not the view tree anymore. And so you also don't have access to things like match geometry effect and stuff like that that will animate for you. Now you need to, if you wanted to use that, you need to replicate that inside your keyframe animator somehow. The final example we'll look at, which you will probably, hopefully, maybe never need, is particle animations using a timeline view and a canvas. But it's an interesting technique to know and to know about and having in your toolbox. We have a heart as an SF symbol in this case and not as a shape anymore. And we want to add a particle animation to that. And we're going to create a struct for this, a particle modifier, in which we draw the symbol, and then in the background we draw a canvas. A canvas is a view that lets you do immediate mode drawing, which is a way to very efficiently draw stuff on the screen. And so instead of saying to SwiftUI, here's a view and render it for me, you are doing the drawing commands there. We can use our modifier now, and we can add some drawing code inside the canvas. So we can, for example, fill up the entire canvas. And now we can see that this canvas gets exactly as big as our heart, well, the reported size of the heart. The way this works is that we're drawing the canvas in the background, and the background receives the size of content. This is why it's that size. And we actually need some space to work with, so we'll add a frame that's 300 by 400 around that, and now our canvas is much bigger than the heart itself. And so this allows us to sort of go out of bounds. We want to draw the heart instead of filling the background. And so we can add symbols, and we can say, put our content view in, and then immediately resolve that inside the drawing closures. So this is a way to pass SwiftUI views into your canvas. And we can draw this heart at 0. And so by drawing the heart at the origin, it actually draws the center of the heart at the origin. And that's just the way things work in Canvas. And we could draw at a different position, but let's first remove that fill. We don't need it anymore. And now we can draw, for example, at 50-50. Then what we really want to do is sort of have our origin at the center, right behind the center of our original heart. And we can do this by translating our canvas, just like you would translate, for example, a CG context. Now we're drawing at 50-50 from the center. If we change it to 0, we can really see that the nil heart is drawn exactly behind the original one. To animate this, we need to keep drawing this canvas over time, and the way to do this is using a timeline view. This is a wrapper view that will call its body every frame of the animation, just like we saw with the keyframe animations. A timeline view is a lot like a CA display link, if you've used those before. And this timeline view will now call that body, and we only receive the timeline context in. That timeline context contains a date, the current date. And for our animation, however, we need to know like how far along are we. And so we need to not just know the current date, but we also need to know when did the animation start. We'll create a state property for this and say date.now, and then the elapsed time of the animation is the current date minus the start time. And this will be 0 at the beginning and then increase over time, of course. We can use this to animate our X position. So we could say that we take X times 10, or the elapsed times 10. And so now our heart moves by 10 points to the right every second in a linear way. No timing curves, no easing, no nothing. We can add a tap gesture to reset the start time, and this will let us reset the animation every time we tap. This is not quite done yet, so we can also add an animation for a Y position, and now the heart moves up and to the right. To make it float up, we could use a sine wave for the X position. So we can say sine elapsed times 30, or maybe increase that amplitude to 50, which looks much nicer. These 3 lines are what we want each of our particles to do. So we'll eventually wrap them inside a for loop, but first we can add a particle struct. So we'll add a particle struct and have a random amplitude. Then we'll also create a state property for the particles and start with an empty array. And whenever we tap, we add 5 random particles. Now we can add a for loop around those 3 lines and iterate over the particles. And if we now run it, we can see 5 particles that are drawn at the exact same position over time. So let's use our amplitude. And now if we tap it, it looks off. It looks way too unrealistic. And this is of course because we also want to have kind of delays or different start times for the particles. We can add a random delay to each particle and say, well, in between 0 and 2 seconds. And now we can compute the relative time per particle. So that's just the elapsed time minus the delay. And this way, we're not using it, so let's add that. So we'll switch it from elapsed to time. And now it's still not quite correct. So if we tap it again, we can see that some of the particles are starting below the center. And the reason for that is, let's imagine we have a particle with a delay of 2 seconds. The current time is 0 seconds, so the time variable in line 19 will be 0 minus 2, so it will be negative. And we only want to draw the particles after they start, after the time is 0. So let's add a guard for that. And now if we tap it, we can see the particles moving up and starting at random times. There's a lot to improve here. You want to remove particles at some point from the array. You want to add particles rather than reset the array, and lots of stuff like that. We can animate the opacity as well. So this way the particles will actually fade in over time. The opacity will become larger over time, even larger than 1. To make them fade out, we can say 1 minus. And you can already see that it's not that hard to write, but it becomes harder to read. And if we want to delay just the opacity, we'll have to do even more time calculations. And doing your own animations like this becomes very tedious and especially hard to read after you get back to it. If we want to make it slower, fade out over 4 seconds, we can just change that variable. And so you can see how you could basically do almost anything you would want in here. It's very flexible, but of course also a lot of work. That's all I have to say, and I'm happy to take any questions also online rather than at a conference. Thank you.